Another name for Sn, the sum of the first n terms of an arithmetic series, it's also called the nth partial sum. So if you see that, same thing, it's Sn, sum of the first n terms, the nth partial sum. You'll see that terminology a lot in Calc 2, actually. Find the nth partial sum, Sn, of the sequence given by an equals 4n minus 3, where n equals 12. So notice what they give you here. They give you an nth term formula, an explicit formula for an, the nth term, which makes the problem pretty much just plug and chug. So I recommend writing down the sum formula every time you use it. Sn equals n over 2 times a1 plus an. And again, I want you to let the formula be your guide. Now, one thing that disturbed me when I was in beginning algebra and went on to more advanced algebra, beginning algebra, the teacher would always give me like a recipe for solving a problem. Here's step 1, here's step 2, here's step, remember that? Wasn't that nice? Comforting? The problem is there's too many problems to solve when you go on in math. And so there'd be too many recipes if I did that in this class. So you're going to let the formula be your recipe. You're going to let the formula talk to you and guide you and let it tell you what to find. Sn, so we want the formula for the sum of the first n terms. We should be able to use this guy. This is the generic formula. We've just got to plug in. Oh, and I'm sorry, they do actually give us n equals 12, so they want S12 here. So we have to use Sn where n equals 12. And we'll be able to find the sum of the first 12 terms. You might say, well, I could do that in my calculator real quick. And you'd be right. But what if it were the sum of the first 1,000 terms? Then you wouldn't want to do it by hand, right? I mean, even if you were using the calculator to do each individual addition, you wouldn't want to do it that way. The formula is way faster. Okay, so plug and chug. Plug in what the formula tells you to plug in. All right. What do you need to use this formula? You need, if it's given to you, you need n, right? And what's n in this case? N is 12. So check. We've got n. You also need a1. What's a1?
According to the red circle formula, it is 1.
Okay, so does everybody see what he looked at? Anytime you're given an explicit formula, you can find a1, you can find a million. It doesn't matter. You have your explicit formula. What do you do to find a1? Plug in. So it'd be 4 times 1 minus 3. So what is that? Oh, it's just 1, isn't it? A1 is 1. And then what else do we need? What? Well, okay, what an in this case, what's n? What's n in this case? 12. So we in terms of n equals 12, we need to find a12. That's what the formula tells us to find. So the formula says find a12 because n equals 12 in this case. Oh, the reason that's important, writing a12 down, is because that tells you what to plug in the explicit formula. So a12 is the 12th term of the sequence. Use your explicit formula to find it. What does your explicit formula tell you? 4 times 12 minus 3? What's that going to equal? 4 times 12 is 48. So minus 3, 45. Okay. Notice how I'm letting the formula be my guide. By the way, if it helps you, there's an additional step you could show. You could say, in this case, make it S12. So Sn is S12 in this case, and you could replace n with 12 in both cases, if that's helpful, and then go down and find A12 and A1, or A1 and A12, doesn't matter. Okay? If that's helpful, show that step in yellow, but you don't have to. So let's go ahead and fill in this formula that I filled out in yellow. Let's go ahead and fill it in with the particular numbers we get from this problem. So S12 is going to equal what? Well, I'll go ahead and write it as 12 over 2 again, although we know that's 6. And then what do we fill in for A1? We fill in 1 plus A12? 45. And then just do the arithmetic. So what's that going to turn out to be? 6 times 46. What does that turn out to be? 276? Sounds right to me. So in other words, if you were to add the first 12 terms of the arithmetic sequence given by the formula an equals 4n minus 3, those terms would add to be 276.